question number 76, which says that the solubility product of barium hydroxide is 5 into 10 raised to the power minus 7, and you have to calculate the pOH of saturated solution of barium hydroxide. So first of all, write the ionization of barium hydroxide. So it will give in the solution barium 2 plus and 2 OH negative. So suppose you have initially 1 molar concentration of barium hydroxide. So at equilibrium, concentration of barium 2 plus S and concentration of OH minus 2S. So you can write it down the value of KSP, that is the solubility product, which is equal to concentration of barium 2 plus multiplied by concentration of OH minus square. Because the stoichiometric coefficient, as you can see here, is 2 in the case for OH negative. So barium 2 plus की concentration कितनी है? S, and OH minus की it is 2S. So 2S square. तो ये कितना हो जाएगा? It will be 4S cube. और KSP की value you have been given, that is 5 into 10 raised to the power minus 7. तो यहाँ से you can calculate the value of S. So it will be equal to 5 into 10 raised to the power minus 3. And now you have to calculate the OH minus concentration. तो OH minus की concentration कितनी है? 2S. So it is equal to 2 into 5 into 10 raised to the power minus 3. So it was equal to 10 raised to the power minus 2. So यहाँ से we can calculate the value of pOH. So which is equal to minus log of OH minus concentration. So it is equal to minus log of 10 raised to the power minus 2. So which is equal to 2. So option number 4 will be the correct answer. So moving on to the next one now, you have question number 77, which says that from the following reactions, you have been given the 3 reactions and you have to find out which of the following options contain all values of enthalpy of combustion. In the first case, there is the combustion of N2O and which is forming NO2. And in the second case, the combustion of C2H6 gas is taking place and the CO and H2O are being produced. And in the third case, the combustion of C3H8 is being done and CO2 and H2O are produced. So the beauty of this question is that first you have to identify whether these reactions are undergoing complete combustion or the incomplete combustion. So in the first case, this reaction is an example for incomplete combustion. And in the second case also, you can see here CO gas is being produced. So this is an example of incomplete combustion. अगर ये complete combustion होता तो कौन सी gas produce होती? Carbon dioxide. So this is also an example of incomplete combustion. अब हम third case में देखते हैं. In the third case, the products are CO2 and water. So this is the case for complete combustion. So we can say that the third reaction is an example for complete combustion. So now we have identified that only the third reaction is undergoing the complete combustion. So we can only calculate the enthalpy of combustion from the third reaction. So now you can see here, जो हमें delta H की value दिया, that is equal to minus Z, which is for the 2 moles of C3H8. And enthalpy of combustion की क्या definition होती है? It is the amount of heat evolved when 1 mole of the compound undergoes complete combustion to form the product. तो यहाँ पे you have been given for the 2 moles. So the delta HC, that will be the enthalpy of combustion, which will be equal to minus Z by 2, which is for the 1 mole of C3H8. So only correct option, that is option number 4th. So option number 4 will be the correct answer. So moving on to the next one now, you have question number 78, which says that if for the dissociation of NH2C double bond O NH4, Kp is 32 atm cube, then equilibrium pressure is. So first of all, you have this example of heterogeneous equilibrium. So at equilibrium, the total equilibrium pressure will be only due to the ammonia and carbon dioxide because this is the solid. So we can say that at equilibrium the pressure of ammonia will be 2p and that of CO2 will be p. So we can write the expression for Kp, that is 2p square, because the coefficient of NH3 is 2 multiplied by p. So here it will be equal to 4p cube, and the value of Kp you have been given, that is 32. So यहाँ से p cube की value कितनी हो जाएगी 8. So the value of p will be equal to 2 atm. And now you have to find out the total equilibrium pressure. So the total equilibrium pressure will be equal to 2p plus p, which will be equal to 3p. So it is equal to 3 into 2, which is equal to 6 atm. So option number 4 will be the correct answer. Let's move on to the next one now. So you have question number 79, which says that which of the following has highest heat of neutralization. So what do you mean by heat of neutralization? So heat of neutralization is the amount of energy evolved when 1 gram equivalent of acid is neutralized by 1 gram equivalent of base. तो अगर strong acid or strong base है तो heat of neutralization is maximum, and if there is a weak acid or a weak base, the heat of neutralization is less because there is some amount of energy which is involved in the ionization of the weak acid or the weak base. So the third option, which contains the weak acid, that is CH3COH. So this is discarded. Now we have all options in which we have the strong acid and the strong base. But in the second option, due to the higher hydration energy of F negative, there is the highest heat of neutralization. So option number 2 will be the correct answer. So moving on to the next one now, we have question number 80, which says that select the correct statement among the following. The first statement says that absolute value of entropy can be calculated. This is absolutely true according to the third law of thermodynamics. And the second statement says that for isothermal expansion of an ideal gas, work done reversible is greater than work done irreversible, but for isothermal compression, work done reversible is less than work done of irreversible. First of all, let me draw the graph for work done for reversible and irreversible expansion and compression. So this is for the expansion, and here it is P1 V1, which is going to the final state, that is P2 V2. So this is the initial state and this is the final state. So in this case, the reversible work done will be this. So this is the reversible work done. So now if I talk about the irreversible expansion, so for the irreversible expansion, the P external will be less than the initial pressure, and we can draw the work done here. So this will be the work done in the case for irreversible expansion. So always work done reversible will be greater than work done irreversible. So now if I talk about the compression case, this is pressure and this is volume. And now this will be the initial state and this will be the final state. And this is the initial. And during the compression, the P external will be higher than the initial pressure. So suppose here is the P external. So the work done will be this. So this will be the work done in the isothermal compression. So which you can see that it is the higher than the reversible work done. So means we can say that work done reversible is less than work done irreversible in the case for isothermal compression. So this statement is absolutely correct statement. Now we have the third statement in which we have been given that at equilibrium delta G naught may be 0. So this is the expression. So we can write it like this: delta G is equal to delta G naught plus RT ln K equilibrium. And you know that at equilibrium delta G की value कितनी हो जाएगी? 0. So delta G naught will be equal to minus RT ln K equilibrium. अब अगर यहाँ पे K equilibrium की value 1 हो जाए तो ln 1 will be equal to 0. So the delta G naught will be equal to 0. So delta G naught can be 0 if value of equilibrium constant is equal to 1. So this statement is also correct. So option number 4 is the correct answer. That is, all statements are correct. So moving on to the next one now.